So 8.2, basic rational exponents. So we're going to start by just reviewing some rules. We have seen these before in Algebra 1, and we have talked about them before in this class too. But we're just going to quickly review through them. So the first thing is when we are multiplying powers. So when we are multiplying powers, if they have the same base, we can just add the exponents. Okay? So for instance, an example of this, if I have x to the third times x to the seventh, would we agree that both of those have the same base? Yeah, which is what? X. And now we can just add those exponents. So this would just be x to the 10th. And that's my answer. Okay, what if I had ab to the third times a squared b? Okay, we can do this. Looks to me like we have two separate bases, right? Two different variables here. So we start with the first one we see, which is a. We add the exponents across, so this would be a to the... Ooh. What's the exponent on this first a? If it's not written, isn't it just a 1? Yep, so 1 plus 2 would be 3. Good. And then b to the 4th. Good. This one would have a 1 as well, if it's not written. Good. Questions on that? Okay. Next up, dividing powers. Works very similar. If we have the same base, what do you think we can do with those exponents? Anybody remember? Subtract. Good. Subtract the exponents. So for instance, if I have x to the 7th over x to the 3rd, thank you. If I have x to the 7th over x to the 3rd, that's the same base. I can subtract the exponents, so this would just be x to the 7 minus 3, 4. Good. Okay, we'll do one more. If I have a to the 3rd b squared over ab, so a to the 3rd over a would simplify to a to the 2nd, because again, if it's not written, it's a 1, so a squared. And then b squared over b? Just b. Good. B or b to the 1st. Questions on that? You guys are smart. Good. Lastly, negative power rule. Okay, negative power rule. This one's a little bit longer to write out. So, when you have a negative exponent, you can move the base and exponent across the fraction bar to make it positive. So when you have a negative exponent, you can move it across the fraction bar to make it positive, okay? How does this work? So for instance, if I have x to the negative 7th power, okay? That's currently just in the numerator, right? It would have a denominator of 1. So what I can do there is I can shift that base of x and power of negative 7, I can make it go down to the denominator. And now it's a positive 7. The x doesn't change, just the negative 7 becomes a positive 7. What would be left on top?
1.
Just a 1. Good. Okay, this also works the opposite way. Okay, so for instance, if I had 1 over a to the negative third, b to the negative 2. Okay, I can bring those both up to the top by making them positive. So this would become a to the third b squared over 1, or just a to the third b squared. Does that make sense? Yeah? Okay. Hopefully we got that down. Everybody got it? Oh, okay. Example 1. Okay, so when we see a problem like this, first thing we do, we check what operation we're doing. If we've got a little star right there, what does that mean to do? Multiply, good, okay? So first thing we're going to do is just start with the numbers, okay? Just like multiplying numbers has always worked throughout our entire lives. So 3 times 7 squared. Okay, what is 7 squared? 49. So basically we're doing 3 times 49. What is 3 times 49? Use a calculator if you can't do that in your head. 147, cool. Okay, now we're applying our rules. So we notice our first variable is x. So x to the first times x to the third would be x to the fourth, good. 1 plus 3 is 4. And then y to the 8th, and that's it. That is all. Okay. Questions on that? No? All right, cool. Then we got example 2. I don't really like the way that this is written, so I'm just going to put the numerator on the top, denominator on the bottom. Same thing, okay. So when we are dividing, first thing we do is we divide the numbers just like normal, but the first thing I need to figure out is what is 5 squared? That's a 25, so I'm going to cross that off and put 25. So I now have 25 over 50. What will that simplify to? 1/2. So 1 would be on top, 2 would be on the bottom. I then have x to the first over x to the sixth. X to the negative fifth. Subtract the exponents, and then y to the fourth over y to the fourth. It's just y to the 0, which we know is just 1, okay? However, can I leave this negative exponent up top? No. What do I need to do with it? Move it down, right? So the numbers are going to stay the same. The coefficients are going to stay the same. They don't move, okay? Just the base and the exponent. So the x and the 5. So that is my final answer. Questions on that? No? Cool. All right, little review of last class, okay? So what happens when we don't have monomial terms that we're dividing, okay? If we have bigger terms that need to be factored. So for instance, on top here, we've got a binomial x plus 5. Can we factor x plus 5, or is it good? It's good. What about the bottom, x squared plus x minus 20? Can that be factored? Yeah, x method, right? What's going to go on the top? What's going to go on the bottom? Two things that multiply negative 20, add to 1. Think about your 5 and negative 4, good. Factors of 20. Leading terms of 1, so we're good on this. We'll keep x plus 5 on top, and on bottom I now have, what are my two factors? What did we just find? Plus 5 and minus 4. X plus 5, x minus 4. Say what? I have one that matches. What is it? Yep, they're gone. What's going to be left on top? 1, and on bottom. And I'm done. That's it. Wow. Okay. Examples 2 and 3, again, this is kind of a review from last class, so I'm going to pause here and I want you to go ahead and try these. Alright, let's go ahead and try this one. So on the top, x squared minus 9. How do we factor that? Close. She said x minus 9, x plus 9, but it's 3. We got to square root both terms. Right idea, though. Yep. 1 positive, 1 negative. So x minus 3, x plus 3. On the bottom, can we factor that? Pull out a 2. Yep. And what's left? Ooh. What? No, that was right. I just said, ooh, what do we see now? Get rid of the x plus 3s. Those are going to cancel. It's just x minus 3 over 2. Yep. Don't simplify any further. You cannot simplify a binomial with a monomial, okay? 2 terms are never going to be 1 term, so don't do anything with that. Okay? And then number 3. It was x minus 3 over 2. All right, number 3. On the top, what can we do with that? X method. We should be getting good at X method. What goes on top? -4, bottom. 2 things that multiply to -4, add to -3. What do we think? -4, positive 1? Yep, that works. So on top, my factors are x minus 4, x plus 1, the numbers I just found. Okay? X method again. Top. 36, bottom. This one's kind of a trickier one. We got to think about this one. What 2 numbers will multiply to be a positive 36 and add to be a negative 13? What'd you say? 9 and 4. Both negative. Yep. So the bottom of this becomes perfect. Anybody see it? X minus 4's cancel. What's left on top? Bottom. Okay, everybody pause here. Do not, and I repeat, do not go like this and try to cancel those x's. Why can't I do that? Well, I don't want you to, but what's the reason? I did tell you not to, but what's the mathematical reason? No. So what do we have here on top? A binomial, and we have a binomial on the bottom. Are they the exact same? No. So they cannot be canceled. That's it. Thank you for coming to my TED Talk. All right. Questions on that? Okay. Last page of notes of this section. Basic operations with rational exponents, okay? So, here's the deal. Our 4 basic math operations in life that we have learned are addition, subtraction, multiplication, and division, right? Yes. You with me? Okay. When it comes to rational expressions, addition and subtraction are actually harder to do than multiplication and division, okay? So we're going to save that for after spring break, all right? Before spring break, today we're going to be covering multiplication and division. So the only thing that your little mini test is going to cover is, number 1, simplifying, and number 2, multiplying and dividing, which is going to be pretty much the exact same as simplifying. When are we taking it? Next week. All right, rule to remember. When we're multiplying fractions, we need to factor everything and multiply across. Factor everything out, every numerator, every denominator, and multiply across. Rules to remember when dividing fractions. First things first, KFC. Anybody remember this from middle school? Dividing fractions? It is Kentucky Fried Chicken, but there's another thing it also stands for. Has to do with fractions. Keep flip change. Cool.
Oh, yeah.
Keep flip change. And then repeat the rules of multiplying. So keep flip change, and then this becomes a multiplication problem.
Dude, I'm saying KFC's nasty. It's so greasy.
I think it might just be the one in Troy, though.
So good.
I've never ate KFC anywhere else other than in Troy.
You don't
And
want
I
greasy
don't want to eat
chicken.
KFC ever again.
You don't like the Troy KFC?
I hate the Troy KFC.
Okay.
It looks weird, too.
Okay. Well, this isn't going to be greasy, okay? This is just going to be
I don't
Is it
plain
gonna be
Jane
based or
math.
cringe?
What?
Is it gonna be based or is it gonna be cringe?
I don't know what that means. I don't want to know.
Cringe.
Okay, let's go ahead and let's solve. So first thing I do, I look at what operation. If I see a star, what does that mean to do? Multiply, okay? I look at each individual numerator and denominator, but I notice these are all monomial terms, right? Meaning they can't be factored, okay? So we're just going to go ahead and we're going to multiply across. So we'll multiply the numbers. 7 times 15, 105, and we'll keep that x squared. Now we're going to multiply across on the bottom. 5 times 14x would be what? 70x. Perfect. And now we are dividing. Okay, we're just simplifying. 105 over 70. What is a number that would go into both? 5. What is 105 divided by 5? 21. And what is 70 divided by 5? 8. Okay. I don't think that's right. 14. Okay. 21 over 14. Will that simplify further? I think so. 3 over 2, right? 7 goes into both. So 3 over 2. And then we got x squared over x. Just 2 minus 1 is just 1. So it's just x on top, right? That's it. We're done. That is all. All right, number 2. What is the first thing that we notice?
It's a division problem.
Division problem, which means Kentucky Fried Chicken. We are going to keep the first fraction the same. Don't change anything. We're going to flip the second fraction. So it's going to be 2x to the third over 6x squared. And we're going to change the division sign to multiplication. You could put a star, a dot, an X, whatever you like to write for multiplication problems. You could draw a piece of chicken, as long as it's round. That's fine. How about a crumb instead? Better. Okay. We are now down to singular monomial terms that cannot be factored. So we'll go ahead and we will just multiply straight across. Tell me what you're going to get on the top. 4x to the 4th over 18x to the 4th. 4 over 18, what will go into both? 2. What's 4 divided by 2? 2. And what's 18 divided by 2? 9. So 2 over 9. And then x to the 4th over x to the 4th. Cancel out. 2 over 9 is my answer.
Brian, is KFC or Chick-fil-A better?
Chick-fil-A.
We all know everyone likes that better. Because they actually know how to cook chicken.
How is KFC if we're not out of it for sale?
I'm honestly surprised Slim Chickens hasn't put them out of business.
I've seen the video.
But,
Slim's isn't that
What
good.
happened?
I mean, it's not Chick-fil-A, but it's,
Everybody says Slim's is so good, but you get there, it's just like chest.
I don't know, but I'm saying for Troy restaurants.
Yeah.
Yeah,
I think
don't know.
everybody goes there just because it's new, not because it's good.
Probably. I don't know. We are doing what operation? Multiplication, okay? That second fraction doesn't really look like a fraction. How do I make it look like a fraction? Just put it over 1. Yep. Cool. So we now look at each individual numerator, each individual denominator, and we see, can it be factored? We'll start with the first thing. It's 9. Can that be factored? No. 12 plus 8x. What can we do there? Take out a 4, and what's left? Plus 2x, good. So we'll cross off that numerator because we now have simplified it. Then we go to 3 plus 2x. Can that do anything? Nope. And then we go to 1. Can that do anything? Nope. So we're ready to go ahead and multiply across. So 9 times 4, my monomial terms, 36. We keep all the binomial terms, so keep the 3 plus 2x. On the bottom, we just have a binomial term, 3 plus 2x times 1, so we'll put that up front. That's my monomial term on the bottom. So now we look, anything gonna cancel here? What? 3 plus 2x, and then I'm left with 36 over 1, which is just 36. Good, that's it.
36 pieces of Maxi KFC chicken.
Okay, we're back on the chicken. Worry about you guys. Okay. Operation on example 4 is what? Multiplication. So I don't have to do keep, flip, change. I just need to start factoring. So I look at my very first numerator. Can that be factored? X method. What goes on top?
This is a lot of X methods.
Negative 6. What goes on bottom? Negative 1. Two things that multiply to negative 6, add to negative 1. Think about it, think about it, think about it. Factors of 6.
Just a second.
3 and 2. And which one is going to be negative? The 3. Good.
Yeah.
So we can scratch out this numerator, and the new one is going to be x minus 3, x plus 2. Good. Let's go. Next numerator. What are we doing?
Same thing as we did last.
Same thing as what we just did. Another x method. What goes on top? Bottom. 2 things that multiply to 12 add to 7. 4 and 3. So my 2 factors, scratch this out, and it is x plus 4, x plus 3. Golden. X squared minus 9 is my first denominator. What are we doing there?
X plus 3, X minus 3.
Difference of squares. We really need to start recognizing that now.
That's what
Scratch it out. X squared plus 4x plus 4. X method. On the top. On the bottom. And what am I putting? 2 and 2. So x plus 2, x plus 2. Is everything fully factored? Yes. So now we multiply straight across, straight across. So here's what I got on top. I have x minus 3, x plus 2, x plus 4, x plus 3. That's everything on top. On the bottom, x plus 3, x minus 3, x plus 2, x plus 2.
Give me a second to rate this.
And now we do the fun part. What's disappearing? X minus 3. X plus 3. Yep, one set of x plus 2. And what we got left? X plus 4 over x plus 2. Can that be simplified? What?
No.
No, why not?
You told us not to.
I told you not to, but why? They're not the same binomial. They're not the same binomial. Gotta know that. Okay, I'm gonna give you about 4 minutes. I want you to do examples 5 and 6. We'll go over them. We'll call it a day. What operation is number 5?
Division.
Division, which means I need to start this problem by doing what? KFC. What am I keeping? What am I flipping? And what am I changing? There we go. Okay, now we look. Can any individual numerator be factored? X or x plus 11? No, I didn't even flip that. What am I doing?
That confuses me. I was like, that does not look right. It's the KFC.
Okay, no individual numerator can be factored. What about any of the denominators? No. Okay, good. So we're ready to multiply across. Here's what I have. On top, I have a monomial and a binomial. Those will never be the same. Leave them alone. On the bottom, I have 2 binomials that, again, are not the same, so leave them alone. Just write them next to each other. Now what do you see? What's left on top? What's left on bottom? Can it be simplified?
No.
Why?
Because
They're not the same. Monomial will not be a binomial. Questions on that? No? Are we good? Everybody got that down? People in the back. You got it? Got it? Got it? Cool. Last one. We can do it. We can get through this week. Okay. What do we notice first? Division. So I must do what? KFC. Keep this one. Flip this one. Change my sign. Perfect. We start. First numerator is what? What's the first numerator that you see? 2x plus 4. What can you do with it? Take out a 2. It becomes 2 times x plus 2. Good. Second numerator. What can that do? X method. What goes on top? Bottom. 2 things that multiply to 45 add to 14. Think about it. Think hard. 9 and 5. Good. So my factors become what? Perfect. Okay, first denominator. Can that be factored? X method. What goes on top? Bottom. We're so close. What are the sides? We can do it. Multiply to 18, add to 11, 9 and 2. I like it. X plus 9, x plus 2. Scratch it out. And then my last denominator, x plus 1, is that going to do anything? No, leave it alone. Okay, here we go. Biggest part here. On the top, just write everything you have. So 2, x plus 2, x plus 9, x plus 5. On the bottom, x plus 9, x plus 2, x plus 1. Crazy. Cross them off. What am I crossing off? X plus 9. What's left on top? 2 times x plus 5. What's left on bottom? X plus 1. Are any of those the same? No, leave it alone. You're done. Done with notes for today. I am very unimpressed by the people who sat there and did nothing today. So if that is you, probably getting an email sent home. Okay? Cool. You know who you are. Homework is in the homework packet. Delta Math is posted. So get going on this. Let me know if you have questions.